All right, now we're in section 9.9. We're going to represent different functions by a power series. Again, we've hit on this a little bit. Some of this is cyclical for just exposure purposes. All right, so here we're going to talk about our geometric power series as a function, different ways to construct them from operations, where last time we talked about differentiation and integration. So we know our geometric series is AR to the n here, where R is our multiplier and A is our starting value. And we know our sum is going to be A over 1 minus R, and that's going to be convergent when the absolute value of R is less than 1. So since we know that, we also know that that's going to come from, if I have a starting value of 1, my A value is a 1, and instead of saying R, I'm going to call it an X, it's going to represent the same expression. So if my A is a 1, so if my A is a 1, instead of using R as your variable, we're using X, that these are going to be equivalent. So therefore, we're going to be convergent when our absolute value of X is less than 1. Clever way to, they just changed the letters around, but it's a nice way to connect that ratio of 1 over 1 minus R, that rational expression. Okay, so if we have our equation over here, right, 1 over 1 minus X, on the interval from negative 1 to 1, we can see that it's defined everywhere but a positive 1 for X because of that asymptote. So that's really no surprise there. Okay, so if we wanted to change it to be centered at negative 1 instead, and this is a little bit of the switch here that needs to happen. So if I want this to be a negative 1 center, I'm changing this X position to be the quantity X plus 1. So in doing that, I really added a negative 1 to that part of the problem. So if we're going to make an adjustment on that, you can see that if we did, we distributed this negative sign, right, we would have our negative X and a minus 1. Well, I guess if you think about it, big picture, then if I have a 2 and a minus 1, that end value is a 1, and that's what we currently had. So by switching over that center to be X plus 1, we want to maintain the value of the problem is the same. That's why that 1 changed to a 2 instead. All right, we want to make sure that we're still in the form of A over 1 minus R. So this 2 in this position is not very helpful. So what we're going to have to do is, you can multiply everybody by a half is one way to think of it. So if we multiply the numerator by a half and then we multiply the denominator by a half, so my 1/2 times 1 gives me the numerator of a half. My 1/2 here times 2 gives me my first term of a half. Then if I multiply my center here, X plus 1 by a half, that's why there's the X plus 1 divided by 2. So now we're in the form. I have my 1 in the correct position. So whatever number is my numerator is my A, and then whatever term is behind the subtraction is my R. So by just changing the center, everything is going to move around a little bit, but you got to make sure you put it in the correct places. Just because we move the center doesn't mean my starting value is going to be a 1, because we move the center, so everything is going to shift to the left 1 tick there. Okay, so if I have the absolute value of X plus 1 is less than 2, all right, how did I get that? Just to make sure you're with me here, right? So if I have my absolute value of R is less than 1, and then I have my X plus 1 over 2 has to be less than 1. Our form is X minus C is what we need to find my radius. So when I multiply both sides by 2, that's how I get the 2 on the side there. All right, so then if I know that I've got my quantity here, 1 over 1 minus X, I have my A, and I'm thinking here my A, R to the N for my geometric series. Right, here's my R, here's my N. I have my half. Okay, so all I'm going to do is take my expansion here. So this 2 is underneath, right? So then when I square it, it turns into a 4. When I cube it, it turns into an 8. And I know we're still going to be convergent, less than 2. All right, starting off, I know my open interval is negative 3 to 1, and then I have to check those endpoints. So a little bit, this is just overwriting it, just so you see in different forms from the sigma notation to the term-by-term notation, how the patterns are going to work out. Okay, so if we have the power series now, if I'm trying to represent the function 4 over x plus 2, okay, I'm going to take my 4 over x plus 2, and this really looks like a over 1 minus r. It has the structure, it has the three pieces. So again, for the 2 here, I can multiply everybody by a half. Okay, so then I've got to do the top by a half. So 1/2 of 4 is 2. 1/2 of 2 is 1. And I want it to be minus r. So we're going to change our sum here to be a difference of a negative, just to make sure we're fitting the terms correctly. And then when I multiply that x by a half, that's why it's a negative x over 2. So again, that's telling me my a is 2, and that's telling me my r is going to be a negative x over 2. I know it says it in writing, but sometimes it's easier if you start writing in a color to finish your thoughts. Okay, so if I have, right, my 4 over x plus 2, I know it's geometric. I have my starting term. I have my r. Right, this guy's not affected by the sigma. The 2 can be pulled out in front. So now if I go from, if I pull it out in front, then my starting number is really a 1 because I pulled it out in front. So from here, I'm going to multiply by my negative x over 2, multiply by my negative x over 2, repeat, repeat, repeat. So I know for my geometric series, I am convergent, right, when my r is less than 1. So then I would end up with x, absolute value of x less than 2. So I'm going to take this 2, multiply by the other side, and the absolute value of a negative is positive. All right. And again, we're not checking the endpoints right now. We're just going through the steps here to verify, checking the endpoints. It's the same task every time. And I don't slow down the conversation with that task. Okay, so now this is just operations here. Okay, so if we have f is represented by this sigma and g is a similar one, but it has just a different coefficient in front. If I wanted to multiply f by some k constant, then my k constant is going to be on the inside. It's going to get that power as well because I'm multiplying it by x. So you can imagine I would have kx then to that power, and then I can pass that power out to all the factors on the inside. All right, so now if I have x to the n, same idea, I would replace that x with an x to the n, so that's going to be raised to the n power that's already there. And if you raise power to a power, going back to Algebra 1, you would just multiply those powers together. If I wanted to add and subtract functions, then I would add and subtract the sigmas here. Our x to the n is common, so you can factor that guy out. Okay, so we have our rational function here. We're centered at 0. So if I wanted to estimate this guy here, right, I can break him apart into using partial fractions. Remember, right, we're going to take our a over 1 factor plus b over the second factor to split them up. Okay, that the advantage of that is I know what these guys are. These are some we're supposed to memorize. Then I would just take that memorized expanded sum and then just multiply it by 2. And I would take that memorized expanded sum, and then together I can add up like terms if needed. Okay, so my 2 over x plus 1, the first term that was there, right, we know it's going to be geometric in this form here. So I know my a is a 2. I know I've got my r then really is negative x is my r. So I took the negative sign on the outside and left the x by itself. The only reason for that is to make sure that these x's are the same so we can group them together. My second term was the quantity 1 over x minus 1. So same, doing a little rewrite to make sure my 1 is first, my r is second, my a is in the numerator. I can have the same process here. Notice the negative sign on the outside for my a constant. So if I wanted to group these two together, the original question here, right, I have my sigma, my first sigma over here, and then I have my second sigma. So there's my 2, there's my negative 1, and we're saying minus 1 because I factored it out. Okay, so if we're going to write it out to the n, x to the n, that's this guy. So then if I was going to add on the second one, just x to the n, right? We know we can put that together in 1 sigma because we're starting and stopping at the same spot. So I can put my plus sign there. So now I can factor out x to the n. Let's do a big bracket there. So if I factor it out, then the only thing remaining after I factor that out is a 1 as a placeholder. Okay, that's where this 1 is coming from right now. Oh, sorry about that. All right, we took that -1 out. So that should have been a negative sign. That should have been a negative sign. That should have been a negative sign. Okay, then you can go from this sigma here and you can regenerate the terms, or you can write down a few of the terms for each of them and then just combine like terms, right? Just get the constant terms together, get the x's together, get the x squareds together. It's really a personal approach. That is our last one for now. All right, see you in 910.